does the least common denominator do that? What is the least common denominator? 14. Least common denominator is 14. It's not even a variable. Okay? Notice I put grouping symbols on the left side of the equation and the right side. I'm going to multiply 14 on both sides. Now, you see those grouping symbols? That means I'm going to have to distribute my 14 on the left side. That's what multiplying both sides of the equation by a number does. Notice my least common denominator, it's not 14 over 14 right now. I'm just doing the same thing to both sides. Multiply on both sides. This is not a new strategy. It just looks a little different because we've increased the difficulty of the equation. And so I'm going to distribute here. Well, that reduces and I get 7x minus 6. I'm not actually doing 14 times 3, guys. I'm reducing 14 and 7 and multiplying by 2 equals 35. Now you're like, oh yeah, that's an algebra 1 equation. That's like pre-algebra. Just add 6, divide by 7. Okay. You do need to consider the restrictions. Do I have any? Do you see any variables in the denominator? No, that was a linear equation. There aren't any discontinuities here. The denominator is never 0. So there aren't any. Am I going to make you plug that in and check it? No, I'm not. You just have to know where to look to find potential extraneous solutions. Okay, second question. Number 2. Scooch up. Okay. Not that much. Couple lines, I guess. Okay. 3 over 2 minus 1 over x equals x over 2. Okay. It almost looks like the exact same question I put up. However, where is the variable? Both sides of the equation and the bottom. That makes it an actual rational expression because the variable's in the bottom. So we're going to start with our domain. X can't be. I now have a variable in the denominator. I need to consider the restriction. It's just 0. It's just 0. Okay? Least common denominator. Because I really don't want to have to solve this as a fraction. I'm like, I don't know what to do. Well, last unit with radicals, we tried to undo the radical to turn it into a polynomial. Same thing. We're going to try to undo the fraction, turn this into a polynomial. And so we're going to take our least common denominator, which is 2x, and we're going to multiply by it on both sides of the equation. Notice that's how you keep the equation equivalent. You do the same thing on both sides. And distribute. Notice the left side is distribution, the right side is just multiplication. You distribute when there's plus or minus. And conveniently, right, as desired, the denominator turned to 1. Step 3, solve the resulting equation. Can anyone name this equation? What type? Quadratic. Okay, how do you solve a quadratic? You go way back to Unit 2. Factor, set to 0. Complete the square, probably factor. Set to 0. As we progress through the year, the starting points become more complicated, but they all simplify to the same types of equations, mostly polynomials. Sometimes with a quadratic, sometimes a little bit higher degree. Okay, and I'm just going to carry my restriction down here just to make sure I don't forget about it. This is kind of important. I feel like that is part of the solution, is to include what x cannot be. Here are the solutions, but here's the number that is not allowed because it results in an undefined values.
I understand that, like, we have to do that, or we are doing that to show, like, what it can why. Like, why is that okay?
Here you go. No, there's a reason. There's a reason. If I were to graph this or something like that, I would want to not lose it, even though this is a different setup. Like if I were going to solve this graphically, graph the left side, graph the right side, that would tell you something about the graph, okay? Let's do this one. Let's see if we can get through this one before the bell rings. X minus 1, x squared plus 3x plus 2 plus 2x, x plus 2, x minus 1, x plus 1. Like, oh man, all right, you just threw it up there. It's a lot more terms to look at. Well, we're still going to consider the domain part, and I'm still going to consider my least common denominator. Okay. Right? We haven't really gotten to the equals yet. I'm just deciding what's the domain restrictions and what's my least common denominator, only because I see adding and subtracting. Right? There's an equals, but I do have some addition here. So I'm going to start by factoring. Right? I can't do a least common denominator until I factor. Okay, so my least common denominator is, I'm sorry I'm not giving you more think time, but I want to try to get this one done before our bell rings. Okay, so there's my least common denominator. I'm going to multiply. Look where my grouping symbols go. Yeah, I'm still going to multiply on both sides of the equals. Notice I'm not multiplying by 1. I'm just doing the same thing on both sides. And distribute. Okay, what equation is this resulting in? It looks like quadratic. So let's try to put all our terms together. Okay. I moved everything left.
Wait, it wouldn't be minus 3x?
No, because you have positive 3x and then minus. Okay. But I check my restrictions. Okay, why do I put them next to each other? Oh, I just got x equals -1, but my restriction says x can't be -1. That's called an extraneous solution. Did I have to plug it in? No. That's why you put your restrictions right next to your answers. It makes it really clear. Okay, it is recorded so you can look it up. There's also a video from second period that has like 2 more examples in it.